welcome to Nation Innovation. Today we are going to discuss one of the core concepts of network analysis. So this will be useful for your GATE and ESE exams. And the concept is of transient analysis. So let's take a question. So we have a question where we are given a circuit. Let me draw the circuit for you. We have this 1 ohm resistor. Again, we have 1 ohm resistor, and across this second 1 ohm resistor we have a switch, right? And this switch is opened at t equals to 0. At this end we have a 6 volt of supply. At this end we have a capacitor. Voltage across it is E1, and this capacitor value is given as 10 to the power minus 4 farad. Then extending this circuit, we have a 2 ohm resistor. Then we have a inductor. We have an inductor of 10 Henry. 10 Henry. We have a voltage across it as VLT. And let's suppose the current flowing through this is IL. So the question is, given this circuit, we have to find the voltage across inductor. So how we are going to solve it? Also, during this video, just keep in mind the approach which we are going to use. That will be helpful for your similar type of questions. So the first point is, since this is a transient analysis, a switch is given which is opened at T, and we have to find the value of voltage across inductor. So let's say we take the circuit as T equals T is less than 0 when the switch is closed. Fine. Let's analyze the circuit at T is less than 0. At this time, if we draw this circuit, it will be like this 1 ohm resistor, again 1 ohm resistor. Since the switch is closed, it will be short circuited. This current, let's say IL, is flowing here. The capacitor will be open circuited with a voltage of VC 0 plus or 0 minus, whatever you can say. Then we will have this 2 ohm resistor, and this inductor will be short circuited with a current of IL 0 minus or 0 plus, and here we have a 6 ohm 6 volt supply. So in this case, if we solve for IL 0 minus, so IL 0 minus will be 6 volt divided by 1 plus 2 ohm, because this is short circuited, so this will not be considered. So only this 1 ohm and this 2 ohm, this is open circuit, so this will be 2 ampere. And if we consider VC 0 minus, if we consider VC 0 minus, the voltage across this will be equals to whatever the voltage will be across this. So twice of IL 0 minus, that will be 4 volt. Fine. So this is the condition for T is less than 0. Now let's move to T is greater than 0 when the switch is open. Now let me draw again for you the circuit when the switch is open. So we will have this 1 ohm resistor. Again we will have this 1 ohm resistor. Now in this case, this second 1 ohm resistor across the switch, that will come into play. This is VC. This we have a 2 ohm resistor. Again we have an inductor. Voltage across this is VL. We have a 6 volt supply here. Now let us suppose the currents. So I'll use a different color for the current notations. So if this current is IL, right, and this current is IC, then this current will be IC plus IL, right? Now the approach is, we will have one KCL equation in this loop, the first half, and the second will be across this, correct? Now let us write the equations. So for the first loop, we will have starting from the 6 volt minus 6 volt plus twice of 2 ohm will be there, twice of IC plus IL plus VC equals to 0. This will be my first equation in the first half of the loop, correct? Secondly, again minus 6 volt plus twice of IC plus IL plus twice of IL plus VL. So instead of VL, I am directly writing as it as V equals to L di by dt. So L is 10 plus di by dt equals to 0. These are my two equations, correct? And if I write the value of VCT, the voltage across capacitor, it will be the voltage across capacitor at time instant 0 plus 1 upon C integration of IC dt. So VC 0 that we have calculated in the t less than 0 part, that will be 4 volt plus the capacitor 1 upon C. So since C is 10 to the power minus 4, so 1 upon C will be 10 to the power plus 4 integration of IC dt, right? Now this keep it separate. Now from the two equations, if we put the value of second in equation in first, so what we will get is IC plus 5 milli 5 mega, sorry, 5 kilo 5 kilo into integration of IC dt plus IL equals to 1. And if we change this equation into Laplace transform, we will get ICS plus 5000 by S ICS plus ILS equals to 1 upon S. Let us say this is equation number 3. Again we have a equation 5 DIL by dt plus 2IL plus IC equals to 3. If we convert it into Laplace transform, 5 times SIL minus IL0 minus plus twice of ILS plus ICS equals to 3 by S. Let it be equation number 4. From solving these equations, we will find the value of voltage across inductor, that will be given by minus 3 into 10 to the power 4 by S square plus 5000 S plus 2000. So if you solve these equations, if you solve this quadratic equation, you will get the roots of this equation as S equals to minus 2.5 and S equals to minus 1997.5. So that you can write it as minus 3 into 10 to the power 4 by S plus 2.5 and S plus 1997.5. So basically this is what you got the voltage across inductor in Laplace transform. So in time domain, if you write, you have to convert this equation again into time domain. So it will be 15.04 e to the power of first root will be minus 1997.5 s, sorry, t, then again e to the power minus 2.5 p. So basically the concept of this equation is, if you are given a circuit with the RLC components and with a switch, and they are asking you any voltage or current across any of the components, then the concept is you have to solve it for t is less than 0 and t is more than 0, or the instant of switching the switch, and then using Laplace transform, that is easy. Using Laplace transform, solve the voltage and current equations and then convert it into back into time domain. Thank you. Keep updated on this channel for more such videos. Thank you.